What if I told you that one of the biggest puzzles in modern artificial intelligence was actually first explored over 2,500 years ago? We're going to dive into a philosophical riddle that connects ancient India to the absolute cutting edge of tech. And you'll see how some of our newest problems are, well, ancient questions in a whole new disguise.
It all kicks off with this really cryptic line from the Vaisheshika Sūtras, a super important text in Indian philosophy. Now, at first glance, it sounds pretty abstract, right? Maybe a little mystical. But packed inside these few words is an unbelievably precise insight into how we know things. An insight that, today, engineers are building right into our machines, whether they realize it or not.
So what on earth does a 2.5 millennia-old idea about reality have to do with machine learning? Stick with me because the connection is way more direct and honestly a lot more mind-blowing than you probably think.
Okay, so to get to that answer, first we have to decode what these ancient words, sāmānya and viśeṣa, actually mean. They are the absolute key to unlocking this whole thing. Let's break it down. Sāmānya is the universal, it's the general concept of a thing. Think of it like catness, the general vibe of what makes a cat a cat. Viśeṣa, on the other hand, is the particular. It's a single, real-world example. So not catness, but a picture of your actual cat. One's the idea, the other's the instance you can point to. But here's the real kicker, the last part of that sutra, buddhaya piksham. It means dependent on the intellect. What these ancient thinkers were saying is that you don't just passively see a category like catness. No, your mind has to perform an active step. It has to group all those individual examples together to form the general idea. It's an act of construction, something your intellect does.
Okay, so hold on to that thought. This idea that a concept is formed by the intellect. And now, let's hit a time machine and jump forward 2,500 years into a modern computer lab. Because here, we're facing a weirdly similar problem. How do you teach a machine to classify what it sees?
Think about it. How does an AI learn to spot a cat? You don't just show it one cat and say, that's a cat. Nah, you flood it with data. Thousands, millions of cat photos. The algorithm chews through all that data and starts picking out common features. Whiskers, pointy ears, fur patterns. And from all those features, it builds a generalized model, its own abstract concept of cat. Then it can use that model to decide if a new picture it's never seen before is also a cat. And this is so important to get. The AI doesn't know what a cat is. Not like we do. It has no idea about purring or chasing mice or knocking things off shelves. All it's done is learn a statistical pattern from the data. And it's turned that pattern into a generalized concept. It is a purely computational construct.
So maybe you're already putting the pieces together. The second we place these two worlds, ancient philosophy and modern AI, right next to each other, you see it. They are describing the exact same process. I mean, the parallel is just stunning. The ancient viśeṣa, the particular, that's just a modern data point, one photo of a cat. The sāmānya, that universal idea of catness, that's the classification model the AI builds. And buddhaya piksham, the idea that the whole concept is dependent on the intellect, well, that perfectly describes what the AI does. The category of cat isn't just sitting there in the photos. It's a construct that only emerges after the algorithm has done its intellectual or, well, computational work.
Okay, so we know what's happening, but how? How does this concept actually get formed in the ancient theory and in our modern code? Well, the answer comes down to one really powerful principle.
The ancient philosophers had a word for it, anuvriti, which means recurrence. And the idea is actually super intuitive. A universal concept, like catness, gets formed precisely because certain features, whiskers, pointy ears, a certain shape, repeat themselves over and over and over again, across tons of different examples.
And how does an AI do this? Through something we call clustering. An unsupervised learning algorithm basically just looks at a giant pile of data points and starts grouping them together based on how similar they are. It is, in essence, hunting for the features that recur the most often, and it uses that recurrence to draw a circle around them and call it a category, all without a human telling it what to look for.
And that's the heart of it, right there. For both the ancient philosopher and the modern AI, repetition is the engine that drives abstraction. The more a pattern shows up, the more it recurs across all those different instances, the stronger and more solid that universal concept becomes.
So, this is a really cool parallel, but you might be thinking, is it just a fun coincidence? No way. This connection goes way deeper. It taps into one of the oldest, most fundamental arguments in all of philosophy. What is the nature of knowledge itself? See, the Vaisheshika school, they were realists. They believed that universals like cowness or catness were real things out there in the world, and our minds could discover them. But then you had their rivals, the Buddhist nominalists, who were like, hold on a second. They argued that universals are just useful fictions. They're just mental labels we invent to make sense of the world. And AI puts us right back in the middle of that ancient fight. When a machine finds a cluster in data, is it discovering a real structure of the world, or just creating a useful label for a pattern?
What this all boils down to is a process called inductive abstraction. It's the fundamental act of looking at a ton of specific examples to create one general rule. It's how we've always learned as humans, and it's exactly how we're now teaching our machines to learn too.
And that brings us full circle, right back to the beginning. This quote from a commentary on those ancient sutras just nails it. A universal is universal because it repeats. It's a 2,500-year-old insight that is literally the logical blueprint for 21st century machine learning. It's just amazing.
It really makes you wonder, doesn't it? If this deep, ancient parallel exists in something as simple as recognizing a cat, what other timeless human questions about logic, reason, maybe even consciousness are we now outsourcing to our machines, maybe without even realizing what we're asking?